So good morning, good afternoon, good evening, ladies and gentlemen, wherever you are in the world. This is Tim Collins, Secretary General of World Stainless. We're about to start our last webinar of 2023 entitled Modular Construction. I'd just like to check before I start that I can be heard correctly. So Joe, could you just confirm the sound is okay, please?
Yes, it is.
Perfect, thank you. So, as I said, this is our last webinar of 2023, and it's a pleasure to welcome everybody to this webinar today. Before I start, a couple of important pieces of information. Firstly, I'd like to thank Dr. Jan Song, our research fellow, who's been with us for almost 12 months now. He joined us on a secondment from Baowu Tisco in China, and he's been a great supporter of this piece of work and done a lot of important research to put this presentation together. So big thanks to Dr. Jan for his support there, and also to Joe in the World Stainless team, who's made sure that I don't go off track throughout the webinars, all of them that we've presented this year. So thank you very much to Joe for her support and sort of keeping me safe and sane throughout this process. In terms of a few practical things, so I'll be speaking for about 40-45 minutes. There will be time for questions at the end. For questions that we don't have chance to excuse me, deal with in the webinar call today, we will give everybody who logs a question via the chat Q&A function a reply. So some questions that we don't have time to deal with will be answered by email a little later. But everybody will get a response. Also, the presentation will be circulated to everybody who's joining the webinar, so there's no need to ask that as a specific question. Obviously, that will be after the event as well. And this recording will be posted to our YouTube channel, so there's an opportunity to watch other things a little later if you want a repeat viewing, even if that's a short snapshot of particularly interesting topics within the webinar. So that sets the scene for today. So without further ado, I'd just like to highlight our agenda. So I'll start with a short introduction, then we'll run through a few topics about what is modular construction, why on earth would you adopt this approach, what are applicable applications for the modular type approach, and then we'll move towards the end into suitable materials. And of course, you won't be surprised that I will talk about the benefits of using stainless steels in modular construction before summing up at the end. So that's today's agenda. So let's start with an introduction. So a few, I think, important facts. There is no doubt that when you look at the generation of GDP around the world, the bulk of that comes from towns and cities, and that's not a surprise. The fact that it's 80% might be a surprise, but it's not a real surprise. But equally, those same towns and cities are responsible for almost 70% of the global energy consumption. Again, probably not a complete surprise. And what comes with that is the global greenhouse gas emissions. That is 70% at the minute. But we have this notion of mass urbanization taking place, which has continued now for some years and will continue. So currently about 56-57% of the global population live in towns and cities. That will reach 60% by 2030 and is forecast to reach almost 70% by 2050. So we understand the significance and importance of towns and cities in our global population. But let's try and put that a little bit into context with some numbers. So as I said, about 57% of people live in towns and cities now. That's 4.6 billion people from a total that's a little over 8 billion people. As I said, that is expected to increase to close to 70% in the next sort of 26 years. So that will jump, that 4.6 is expected to jump to 6.7 billion people out of a number that's close to 10 billion. So in order to deal with that, we have to, I believe, think about construction in a different way, because we have to accommodate this expected population increase, but equally we have to feed people. So it would be absolutely crazy to just eat up, to use that expression, agricultural land. So then you'll have to think about not building sideways, so to speak, but building upwards, or repurposing facilities in a different way. So let's now reflect on a number of features affecting the construction industry. And the first thing is, over the last 10 years or so, we've seen increasing build times. This is an example from Australia, but for many other countries, the trend is the same. And whether it's units, flats, apartments, even houses, the time to build has been increasing. And the trend has continued after COVID. And behind that, there are a few key reasons. Skills shortages exist all over the world, timber shortages, and that's not a complete surprise, but equally supply chain disruptions. Post-COVID, we've seen more and more supply chain disruptions. And whilst we still have some big global supply chain routes in place, there's been more disruptions to those routes, and we haven't yet sort of reached the notion of regionalization in our supply chains yet. So that's one feature. A second feature is the environmental impact, which we really can't afford to overlook. And just a couple of years ago, data from 2021 showed that the building and construction industry at a global level represented around 37% of the global operational energy and process related CO2 emissions. And you've got, of course, different aspects to that. The use of fossil fuels in buildings, electricity use, which is a sort of indirect emission. But you can see from the pie chart here how that 37% is built up. So there is no doubt that when you think about traditional construction approaches, it has a big impact on our CO2 emissions around the world. Now, what's interesting with this, an important feature, because we have a lot of discussions about reducing the emissions associated with producing materials, whether they go into domestic applications, into buildings, into other structures, whatever we think about. But when you consider building and structures, the operation of those buildings is where 3/4 of the total process emissions are generated. So the material, and this is an average figure, and so the material element is only about 25%. And I think we have to hold that notion in our minds. It's really important. Let's also look at safety. It would be wrong to sort of not consider safety profiles. And this is looking at fatalities specifically. It's from the US. The data's a few years old, but again, you look at other countries, you see similar, very similar profiles. And what's interesting is that when you look at fatalities, construction sits in the worst position at the top of this chart. And from my background, being in manufacturing, there's a staggering difference that construction delivers about 3 times the number of workplace fatalities compared to manufacturing. And what is very interesting within this is the same hazards and risks sit in the top 3 or 4 reasons for fatalities in construction compared to manufacturing. So the issues are not different, they're just not handled and managed and avoided in the same way, which is very interesting. It's a really interesting reflection. And I think it shows where different industries sit on the sort of development curve of health and safety practices and approaches. So, having tried to put a few things in place and highlight a few issues, I think to sum this first section up, there is no doubt as mass urbanisation continues, we need a different approach to accommodate more and more people in urban settings. And I would argue, and I'm hopefully going to demonstrate to people, that modular construction is a compelling option to consider, because within modular construction, you're simplifying design and manufacture. There is a standardization process there. The assembly and installation is rapid and much safer than traditional manufacturing because you are taking a lot of the hazards away. But you can still have flexibility, whether it be used for homes, offices, educational establishments, medical centres, whatever. And when you choose the right materials, you can disassemble and relocate in a very efficient way. So overall, you get cost and speed reductions compared to traditional construction methods. So that's my introductory summary. I'd now like to move forward and try and describe a little bit about modular construction to put things into context. So what is modular construction? It's a total factory prefabricated system for buildings. And it includes four core components: the structural system, the thing that holds everything together and makes these structures safe. Then there's the peripheral protection system, the services, equipment and piping system, and then the thing that people often find very attractive, the interior facilities and decorative aspects of the system. So those are the four elements that make everything up. And when done correctly, modular construction is based around easily transportable prefabricated units, which are then delivered to sites for final assembly and connection. And you can see in the image here an example of a tall accommodation block built from modular units, and all the verandas and the balconies, verandas, windows that you can see almost as a pop-out feature are designed within these modular units, and they can just be opened out when you get to the assembly site. Now, there are two basic approaches to modular construction. There are 3D volumetric modules. So these are pre-assembled in a factory and then shipped on a truck or on a trailer. They tend to follow the 40-foot container profile and fit very nicely from a transportable perspective. And there are also 2D panels that are then put together on site. And you can see at a glance the difference. One is very easy to deal with, one has a bit more assembly time. But the advantage of the 2D approach is that you can augment 3D volumetric systems with additional 2D panels and extend in a more innovative way the whole modular concept. Now, it's not a surprise that the 3D approach is the most popular. It's simple. Everything pretty much happens off-site. The modular units are created, and then on-site, you're essentially looking at connections. It's putting these things together, rather like, in a very simplistic notion, putting Lego bricks together when you were a child. And you can create lots of things, as I've said, whether it be apartments, hotels, and there are a number of hotels now that follow this modular approach, medical centres, etc. And the approach is suitable for both permanent and non-permanent installations, so nomadic installations. They can be there for a few years, a few months, and then moved. And as I said, the 2D panels can be used to augment the 3D system, and that gives some bespoke elements to the structure overall. So we're not just creating a McDonaldization of construction, it can be flexible. Now, as I said, the 2D panels have some uses in terms of logistics and construction flexibility. The modular units themselves are simpler to transport because it's like a flat pack system in effect. And the common examples of these include frames, so effectively what you call a two-dimensional frame, beams, columns, wall panels, etc. And whilst that appears very interesting because you can create this flat pack concept, and that should, in theory, deliver a reduction in transport costs, you do have to remember and take into account that you've then incurred additional assembly on site, which then increases costs. So it's a trade-off. I'm not saying 2D panels don't have their place, they absolutely do, but you have to balance things off when considering out the total cost of the installation. So why on earth would we adopt a modular approach? We've had construction systems operating for many years, and people are very proud of that industry that's been created, and some great structures have been created. Well, I would argue there's five business imperatives that need to be considered when you're thinking about why adopt modular construction. The first is speed, and this is quite dramatic. That in many cases, when you think about modular approaches, you're taking the total lead time from a number of months to a number of weeks, where that number is the same. So in other words, if it took 12 months from start to finish with traditional approaches, you can go with modular down to 12 weeks. And this is a huge benefit. So we have to see this as an interesting paradigm shift in construction approaches. Then you've got cost. And of course, the benefits are quite variable here, depending on the complexity of the structure and how it's augmented with other features. But you will at least get a 20% cost reduction, and in many cases, much more when you compare the modular approach to traditional manufacturing. And that's even when you include more expensive materials, which I'll illustrate later in the webinar. Then it comes to safety, and you eliminate the high risk tasks with modular. And because, as I said earlier, the same top three accident categories exist in traditional construction as in steel production, then you're taking away a lot of high risk tasks, a lot of accidents, and of course, fatalities that follow that profile. So from a safety perspective, it is a huge step forward. These systems also offer flexibility. You're not buying a caravan or a sort of road vehicle fitted out for recreational use. You're buying something that can be designed for flexible use, and that flexible use can be adapted over the years. And then finally, the accuracy is really interesting because the units are produced to very tight tolerances each and every time. They tend to be sort of laser or water jet cut. So you get dimensional tolerances of around plus or minus 0.25 of a millimeter in terms of length, width of things, or even better. And this has been achieved now. So when you come to assemble these things, they fit each and every time with precision. Now, just thinking about this notion of why adopt modular construction, this approach supports a need for affordable housing, which is an issue that is discussed in many countries around the world. And because you prefabricate, excuse me a moment, then it helps to mitigate the labour shortages and the skills shortages that have sort of been a problem for the construction industry all across the world. So because of this notion of prefabrication, you're eliminating a problem in the downstream supply chain. The standardized approach, as I said, reduces costs, it shortens lead times massively, and you get this consistent quality. That's not to say that when people are building traditionally, they're not trying to be consistent, but if you standardize more and more things, your consistency of quality increases. And the image here shows a hotel in New York City, and all the rooms are modules fabricated in Poland and then shipped to the USA. This is a bit of what I call product tourism. We're moving things a long way. But once you've created these modules, the movement is easy because the profile fits the standard 40-foot container footprint. So it's very easy. And this approach, I've stayed in one of these hotels. They're very modern, very functional, and very interesting as a sort of new traveller using this sort of approach. So I can see the benefit. This will replace many traditional facilities that we probably quite like, but hey, this is not bad. This is really good. Also thinking about it, we can't ignore the rural settings. Urban settings are where most of modular construction, I think, will move into, but because you have very good practices that are sustainable associated with modular construction, you can't overlook uses, and probably in a more simpler form, in the rural environment, because you minimize waste, you reduce energy consumption, and you can very easily employ the eco-friendly materials in this process. Because what you tend to be using in modular construction is materials that are resilient and durable and very easy to recycle. So you've got the notion in this of both reuse and recyclability all wrapped up. So they fit well, as I said, in rural environments too. Now, as we get to the end of this particular section, this is an example from the whole-on building concept that has been used quite well now in China. And this is an example of the bill of materials for the modular units. And what you see here, I'm not going to read this all out, is just 12 items. So this is a really important feature, that the overall bill of materials becomes simplified. You're working with standardized components, and they can be produced very quickly to order. You're not producing to stock, so your inventory holding drops too, and this is then very easy to put together. So the bill of materials aspect is really helpful when you consider the modular approach. So to sum up why I believe modular is good, is those top 5 business imperatives that I laid out early in this section are significantly improved. And I'll demonstrate that later with a couple of real world examples. The system, the approach, the notion of modular construction does overcome a number of perennial problems that the industry faces, whether that be labour shortages, supply chain disruptions, or whatever. And as I've said a moment ago, the bill of materials is smaller and standardized, which becomes very helpful. So when you put these things together, you get a supply chain that is simplified, and simplification delivers reliability. That's a well-proven feature. But you can still have flexibility. And that's quite an important feature, because people are very, or find the requirement to have some flexibility. It's a very personal thing. So being able to offer that is a big prize in the modular approach. So that's why I believe we should adopt modular construction. But let's sort of roll forward now and think about applicable applications for this approach. So I'd first like to start by outlining the whole-on building concept, which is something that is produced by the Broad Group. These units are put together in China and then transported. And the example here is what the whole-on building people call the Garden A1 building. And you can see on the left in the photo the prefabrication that occurs in the factory. It looks very much like a car assembly line. And that's the notion of bringing the automotive thinking into construction. So that allows just-in-time feed of components as these prefabricated units move along the assembly line. So the concept is very simple, and it's a proven concept in other industries. So why not adopt it in construction? And what's impressive about this concept is you can very quickly build a useful building. And the Broad whole-on building concept has a lovely sort of tagline called 10 or 11 stories in one day, and they actually installed 11 stories in 28 hours, which is an amazing feature because it's easy to transport. You can see the modular units there on trucks in the middle image, and then the assembly is sort of dropping these things essentially side by side, one on top of another. Of course, you need to have the foundations and base in place first, but I mean, that's something that can run in parallel with the creation of the modular units. So it's a very fast system, and that's impressive. But let's look at this from a different perspective. And this is a model of life cycle emissions that I'm very grateful for Jan doing all the research here and putting this together. And this is in 3 sections. If you look to the left, the first 2 bars here, you have the first year of creation of similar sized buildings, one through the Holon system, one through the traditional system, and you can see the CO2 emissions in terms of kilograms per meter squared of floor space. They're very similar, not much different. So taking that view, you'd say, hey, is this important? Is this impressive? Is it a seismic shift? Probably not at year 1. But as you roll time forward, when you get to year 50, then you start to see a difference emerging. That the traditional building system in its operational phase is emitting more CO2. And that's because it needs more maintenance interventions than the Holon system does. And you take that forward further to 100 years and that gap opens up. So when we start to think about different approaches for construction, you have to adopt some longer term thinking as well. And then you start to see the emissions difference. And of course, that profile would continue into years beyond the 100th year. And an interesting feature about the Holon building concept is the structural components are all based around stainless steel, as I'll show you in a moment. But that's why you get the lower emissions, because you're using resilient materials that don't require interventions. So let's just try and sum up the Holon system. This is very simple because the prefabrication is 100% within the factory and the assembly is 100% at the site. It's very simple. There's no additional inputs needed. So it's been sort of streamlined into efficient operations. There's a complete use of stainless steels in the structural component. It's about 5 tons per modular unit. This is a 40-foot base modular unit. And when you look at another features and compare another few features and compare those with traditional construction, you have very little construction waste because this is modular. It comes pretty much ready to go. The speed is fast. As I said, we're going from months to weeks. It's typically around 10 times faster. And the cost is at least 20% lower, even with more expensive materials like stainless steels, and in some cases up to 50% lower. So you get a lot of benefits through this thinking. I'd now like to move on and give another illustration. This is a modular footbridge that was originally developed for railways, and this is absolutely a paradigm shift in footbridge construction. Again, stainless steels are used in this, and even with stainless steels, you get about a 33% reduction in total capex costs and an elimination of almost all the welding. So this is a very interesting system. It's also produced from readily available stainless steel components. So let's look at it. So it's primarily constructed, if I can get my words right, from a lean duplex stainless steel. And for a bridge that spans 2 rail tracks, which is fairly common, you need about 65 tons of a lean duplex stainless steel. The lead time is reduced when you're dealing with railways. You've always got complications of taking possessions of track work and things like that. So the lead time is reduced from more than 9 months to somewhere between 9 to 12 weeks. And that's start to finish from placing the order to installation. The operational life is doubled to more than 100 years with minimal in-service maintenance. And standard stainless flat products, plate products, between 6 and 15 millimeters thick is what's needed for the bill of materials. And these are all cut out and the forming of them into structural components is fully automated. So it's a very simple to produce system. And the fixings are all a standard 316L austenitic stainless A4 structural bolt. So nothing complicated in the bill of materials here at all. Now, just to try and sort of illustrate this a bit more. So all the components here are laser cut to size. We have this very tight dimensional tolerance of plus or minus 0.25 of a millimeter. As I said before, they're forming into the components, and you can see a collection of components for the top of a stairwell here. It's fully automated. It works with textured finishes, which make it resistant to blemishes and surface features that would probably make the surface look a little more undesirable, and scratches and things like that don't sort of show up at all. Assembly is the only manual process, and it goes from sub-modules to completed modules off-site in the factory. And then, rather like the whole-on concept, all these modules are brought together and then bolted on site in less than 48 hours, sorry, I should say, based on a 2-track system. So I would argue that this approach is a game changer when it comes to footbridges, and it doesn't have to just apply to railways. As I said, it's produced from standard stainless flat products which are readily available. The capex cost is much lower. Almost all the welding is eliminated. You reduce, in the case of railways, the line access permissions and isolations that are needed, and the total lead time is slashed. And this is a regular feature of the modular approach, that you're really reducing the lead time. So if we need to move fast to do things, when we have a big disaster, this is all possible with this system. So when I think about then these applicable applications for modular construction, and I've only illustrated 2 here, there is no doubt that modular permits a large degree of novel thinking. You can choose higher cost resilient materials to replace traditional choices and still get lower costs for the project overall. And using those resilient materials gives a massive reduction in costly maintenance demands. And if you think about something like railways, even to undertake maintenance, you've got to isolate and get access permissions around the track work. So you're adding complexity that with this system and the right choice of materials, you avoid. And also those resilient materials reduce life cycle emissions. And with this approach, you can have fast response, you can have flexibility. So if we have a natural disaster, you can offer up quite quickly with modular support units. You can offer up facilities that can be converted into short-term need hospitals, like the pandemic we've just come through, or perhaps in some cases we still have a number of people suffering. But you can be so flexible with this approach, and you can move these things around, as I said earlier in the presentation. So let's move forward and think about suitable materials. I know the examples I've talked about already use a high proportion of stainless steels, and that shouldn't be a surprise to the audience here. But if you look at modular construction and break the units down into these 4 component parts of structures, the enclosure itself, the equipment that goes in, and the interior decor, etc., then when you look at the big consuming elements of that, structures and the enclosures, you're probably going to consider in the main 3 materials: wood, concrete and steels. And in the steels group, you've got carbon, traditional structural steels and stainless steels. And that shouldn't be a surprise. And that's where most of the weight in a modular unit sits. So we don't need to pay much attention to the equipment and the interior decor. And if we start to compare those 4 materials, looking at a number of important features and attributes, and I'm not going to read out all these things, you can see the sort of color coding on the chart. Red is the weakest suitability. That doesn't mean it's not suitable, it just means it's poorer than others. Green is the best material suitability. What you see is quite a range of sort of or degree of variability of the features and attributes of the different materials. And I'm not suggesting you should ever focus just on one material here, but you can see there is no doubt that when you start to look at the steels group, stainless steel does have more positives than negatives. Carbon steel is fairly acceptable. Concrete and wood have a few weaknesses, but that doesn't make them necessarily bad. It just means we have to think carefully about where we use them. So from an attributes perspective, you can see how we should perhaps consider materials thinking. Now, of course, when people talk about stainless steel, they say, hey, it's expensive. Yes, it is. But when you think about the operating life, stainless is probably one of the better options you could consider because it doesn't require maintenance and ongoing treatments like other materials do. So the cost dimension is really interesting when you start to think about these materials. Now let's just reflect on choice of materials now by looking at the hole-on concept and the modular bridge concept. And in the hole-on concept, almost 3/4 of the material usage is stainless steel, which might surprise people. And when you look at where that stainless steel goes, it's primarily in the structural components. There's a few additional features around the balconies and other decorative elements, but pretty much all of it is going into the structural components. So it's a heavy alignment to stainless steel. And I'll explain more about that shortly. This is the buildup of the structural enclosure systems, and I'm not going to read every element here, but what you see is the sort of strong use of duplex stainless steels, which have high strength and good in structural applications and provide good to excellent corrosion resistance as well, alongside, for other features, austenitic or ferritic stainless steels, which are perfectly suitable for tubes, for panels, for steps and hand railings. So it's an appropriate use of different types of stainless steel here. If we then compare that with the bridge, the modular bridge, which has often been termed the Ava bridge because of the way the components look, they look like the letters A and V when stood side by side, then pretty much all of this is stainless steel. There's very little other materials, notably glass and a few other materials used. But stainless plate for the bulk of the structure and stainless fixings, as I mentioned earlier, are very much all, the lion's share by a long, long way. And what's important is the choice of a duplex stainless steel for the structural components because you get this very high strength, much higher than traditional structural steels, and you get all the benefits of a lovely surface finish, corrosion resistance, minimal maintenance. So if we think about suitable materials, I would argue that stainless steels are a smart choice for modular construction because when you're thinking about structural components, duplex stainless steels are a perfect fit. High strength, good corrosion resistance, relatively easy to work with. And those resilient attributes tolerate what I call a construct, deconstruct, construct cycle. You can put something up, you can take it down, you can put it up again, and it's just the same. And whilst it is much higher in cost, it's very much offset completely and more by reduced maintenance needs, which will be minimal, and very much reduced manpower costs. But also we need to think about stainless steels from a life cycle perspective, because when you choose stainless, yes, you invest a bit more up front, but life cycle costs are always significantly lower because you need less interventions. You need less maintenance. So that's much better overall. It's a fit and forget type solution. And the life cycle emissions, as we showed with the hole-on building, are also massively reduced. Resilient materials don't need to be cared for in the same way. You need to select the right resilient materials at the start and then allow them to do their job. So let's touch on, as we come to the end of this, what are the benefits of using stainless steels in modular construction? And I've touched on some of these things before. Significant cost reduction. In many cases, you will get a reduced capex cost. The bridge is a great example there. In all cases, you'll get a reduced life cycle cost because you're avoiding operational problems and maintenance. You get a long service life. You will get 100 years plus comfortably using stainless steels. And that's including the times you build, deconstruct and rebuild. And you can reuse and relocate very easily. these things do essentially do what they say on the tin. You can repurpose, relocate. Concrete structures are more difficult to relocate. They do degrade, particularly in urban and coastal settings. And traditional structural steel units, whilst they are very easy to repurpose and relocate, they do degrade over time. They do corrode. Even with coatings applied, the coatings fail. Stainless steel doesn't have that problematic feature. And let's just reflect on that. And these are three sort of simple examples. If you look at the picture on the left, carbon structural steel units, we've all seen things like this. They rust over time, even if they've been coated. So you're attracting a maintenance need. Concrete structures, very effective, but again, they degrade over time. And particularly if you've got chlorides in the atmosphere, CO2 in the atmosphere, and sulfate ions particularly, which sort of cause concrete to spoil and crack. And what's interesting is when you think about repairing these things, because they're absolutely repairable, 60% of repairs, particularly to concrete structures, fail within 10 years of the repair being completed. So you're already choosing a route that is likely to be doomed to failure. Whereas stainless steels, because they're corrosion resistant, they don't degrade in the same way. You don't have the same problems, so you can reuse and relocate in a very simple and straightforward way. Now, also, we touched on earlier, low emissions profile. If you choose materials that do not degrade over time, you attract a low emissions profile naturally, because it's the interventions that cause the higher emissions. Non-resilient materials do degrade over time, even if you try and put protective coatings on. I mean, there are some great examples of structures around the world that have to be constantly painted to avoid degradation and corrosion, and that comes at a higher cost, and it comes with an increasing emissions profile. And maintenance interventions are the things that add to the emissions profile. And I think we should all be thinking about how to have minimal maintenance. It's not about not doing it, cutting back on maintenance. It's about choosing materials that avoid or minimize maintenance, because 60 to 80% of emissions associated with structures are in that operational phase. So let's do something about that. And this chart here, as we get to the end of this presentation, actually illustrates in the whole on building concept what happens to three different materials: stainless steel, a carbon structural steel, and concrete from an emissions perspective. And again, this emissions graph is based on kilograms of CO2 per meter squared of floor space. And this assumes that you relocate after 60 years in service in a location. So there's an interesting assumption here. And what you see is at the start, the carbon steel materials have the best initial consumption. And that serves well for a few years. But then that starts to increase as interventions are needed. Concrete sits somewhat higher, but also has interventions kicking in after around 10 years. And stainless steel as a material choice has very little interventions. There's no big uplift. There's a small uplift in emissions when you come to relocate. As I said, this is designed at 60 years. But you see the impact of choosing materials that are less resilient. So when we think about materials choices, we have to think about not the first few years, but the operating lifetime. And I think it should be imposed on us as a requirement to make structures last for at least 125 years, not to last for the foreseeable future. And I think we should also recognize that if we live twice as long as we do today, would we think differently about our material choices? So let's now look at the benefits of using stainless steel in modular construction. I'm going to put together a little diagram here that has increasing cost from the left-hand side across to the right. And we'll put traditional and modular construction side by side. So let's start with materials. When you have traditional construction, your materials are undoubtedly going to be cheaper. When you've got modular construction, particularly with stainless in line, it's much more expensive. And this is often what puts people off, this upfront material cost. Then you get to fabrication and manpower. There's more needed for traditional construction compared to modular, but at this stage, modular still looks more expensive, although the gap is now starting to close. When you get to the delivery component, with traditional construction, you've got such a huge bill of materials that you have significant delivery costs. With modular, everything's been condensed. You've got a much smaller bill of materials, so you have lower delivery costs. And now the outcome is coming close to being on a par with each other. Installation and manpower, modular is much, much simpler and faster. So of course, now the cost difference starts to open up. And then when you get to maintenance, for modular, it's very small, very limited, but for traditional, it's ongoing. So it's in these latter two stages, the installation and manpower costs at the point of installation and the maintenance costs, where the difference opens up. So this is a very interesting reflection, just from a simple cost analysis, that we have to think beyond that upfront cost and to start to think in terms of whole of life costs and whole of life benefits. So the low cost option is always achieved, I would argue, by using resilient materials, because you get those benefits over the long term. So I'd now like to sort of sum up before going to questions. 3 slides to sum up in. Modular construction is growing in popularity. But what's worrying is that many countries, whilst they understand that modular construction is useful, do not have strategies or policies for resilient construction. And that's particularly important when you consider extreme weather, which we're seeing in all parts of the world today. As I've said, modular construction offers many benefits. You can use highly resilient materials effectively and still deliver cost reductions. You can standardize and simplify the bill of materials. You can produce things and install things quickly from readily available products in the supply chain, and you can still customize and repurpose structures easily. Now, I've said this a few times, but stainless steels are often overlooked for construction use because people say, hey, they're expensive, can't afford this. Or people equally don't know about the structural grades that are available. And yet, there are lots of examples where stainless steels have been used and the results are stunning. The Chrysler building in the USA, it's more than 90 years old now. It's only been cleaned 3 times, I believe, with normal household detergent. Still looks pristine. Bush Lane House in the UK, in London, is approaching 50 years old, built in 1976. This was built with partial use of duplex structural components, duplex stainless structural components. They're in perfect condition, no maintenance needed. The Caladana Bridge in Spain, in Menorca, is approaching 20 years old. It's a stainless structure. You can see a part photograph of it to the right here. No corrosion found after 18 years. That was an inspection this year. And one of the very new bridges, which is impressive, the Hong Kong Zhuhai Macau Causeway in China. It's only 5 years old, but it's been built for 120 years of minimum service life with minimal maintenance and has a significant use of stainless in that. So we have some great examples, but we need to think from a modular perspective that we've got a family of materials that would help us. We have specifications and standards available that make the selection of stainless steels much more straightforward than it was in the past. And I'd like to leave people, before I move to the final slide, with a thought. We often experience turbulent times, as we are doing now. And in times of turbulence, it's not the turbulence that is the problem. It is acting with yesterday's thinking. And Peter Drucker, who was a great management guru, is sort of assigned to that statement. I think it's very valid today and well into the future. So, to close this, Modular construction allows for a rethinking of material choices, and I really think we need to do that. Stainless steels offer an unrivaled performance when it comes to cost and emission outcomes, but it is all about appropriate selection of the type of stainless. There are more than 200 different stainless steels available, so you have to choose the right stainless for the right use, and then you get this near perfect performance. So I'd like to thank people for their attention and go to questions. Joe, do we have any questions?
Oh, hello, sir. It's me, Kashan from China. It was a nice presentation. By the way, I saw everything and I actually understood because my PhD is related to this modular construction. So
Okay.
yeah, I have published few papers and I'm very interested about the topic. I have received your email, so I was like, I have joined this webinar, and in the night you also have one of the webinars. I'm looking forward to that. I have a question, only one question. That we have like so many engineering applications of modular construction with those carbon steels, which we call the traditional one. So like B2 that in America and Croydon Tower in UK. So they are working pretty well. Even though I'm also looking to see the stainless steel applicability in these structures, and I feel that what you just told about like maintenance cost, life cycle, and these costs are much reduced, and your corrosion resistance. So why we have to move all of our concepts to stainless steel from their traditional carbon steel only because of these two things? Um, are they creating some they have some kind of practical problems that we have faced in already applied engineering structures of modular? So some of the things I would like to know why we should move from carbon to stainless in terms of modular.
Sure, and perfect question, of course, thank you. Um, I think when you look at what's happening around the world, there are certain regions of the world, and I didn't mention this specifically in the presentation. When you're thinking of marine environments, coastal locations, environments above the snow lines where de-icing salts are regularly used, um, where corrosion occurs much faster than in other regions of the world. So when you start to look at those environments, once you start placing traditional structural steels into those environments, their lifetime is limited. And we've seen around the world in recent years a number of structures that have collapsed. And by using stainless, you avoid those problems. Now, I think we need to be a little careful here in how we think of it, because from a modular perspective, when you consider something like the whole on building concept, you have great flexibility. It's more advanced than other modular structures. And if you want to get the best out of that, you should choose a material that's going to give you more than 100 years of life for the structural components. And stainless will serve that problem, or will fix that sort of requirement, I should say, and overcome all the problems associated with corrosion, and handles deconstruction and reconstruction really well, much better than other materials. So you've got a material family there that can fix a lot of other dilemmas. But it is important to think about regions of the world. Now, another feature is when you're building structures, particularly in areas where you have corrosion problems, you don't always need to use 100% stainless. The notion of selective use of stainless in structures has been around for more than 15 years now, and there are some great examples around the world of where stainless has been used selectively to prevent corrosion in hard to access, hard to maintain parts of structures, or particularly when you think about reinforced concrete in the first subsurface layers of reinforcement. So I'm not necessarily advocating you switch everything to stainless. I think you have to think about the environment. But certainly when it comes to modular, you will get more advantages, particularly if you're thinking about relocating your modular structures by choosing stainless. I think equally the sort of bridge, the railway bridge example I offered, what was interesting there is that compared to traditional structural steels, the smart use of stainless allowed overall a cost reduction because you took away all the manpower intensive components. And that was the impressive shift there. So I think you have to think about the operating environment and your high cost components. It's not just about materials cost. When you lay out how the cost is built up and you say, hey, there's a huge manpower cost here by using a traditional material that I can avoid by using a resilient material. I think the fundamental question is why wouldn't you do that? Why wouldn't you shift the approach? Because I think it always makes more sense to use resilient materials where you can. Extreme weather is hitting us all over the world. So I think we have to remember that and say, okay, I'm not necessarily sitting in a coastal location, so I don't have chloride corrosion problems, but I am sitting in an area that is now seeing increasing extreme weather, and a more resilient material choice will provide operational longevity when you're dealing with those conditions. So I think we have to think about a number of factors. Location. Are we in a corrosive environment? Are we going to experience extreme weather? Do I need to think about the ability to move these things around? Because that's one of the benefits of modular. And could I then in future being in an awkward location? I hope that answers the question. I don't think that modular should replace everything. I'm not suggesting that. But what I think is when you look at the total cost, both of creating an installation and operating the installation, then resilient materials will serve you well and reduce your costs massively. So it's why wouldn't you think about it rather than why do I need to think about it? Hope that's okay for an answer.
Thank you so much. Yeah, that was the most convincing answer I got. Thanks, Tim. Thank you so much.
No problem.
We've got some more raised hands, although we've gone over
Sure.
time.
No
But
problem. We'll do them.
there's one more question. How cost will go down 20%? Because stainless steel is in 316L or duplex, and that's more costly than others.
Yeah, and I may have partially answered that in responding to the previous question from the gent in China. But fundamentally, it's about understanding your total costs. And absolutely, stainless is way more expensive than a structural steel or other materials. And that's often what frightens people. They look at the cost of a ton of a duplex or 316L stainless compared to a ton of a structural steel, and you can feel the palpitations. It's like, oh my God. But with stainless, what you have to recognize, and with modular, is that those higher upfront material costs and utilizing the high strength of duplex stainless firstly allows you for a total reduction in material weight. So duplex stainlesses, particularly with their really high strength, will allow you to reduce the total material weight. Now that doesn't offset the total cost increase at all. But then applying the modular concept reduces your manpower costs particularly massively. So it's those two combinations together that allow you to make an overall cost reduction. And then when you move into the maintenance area, you don't have ongoing problems. So the cost reductions come through a different piece of thinking and putting the total costs together. As I said, in some cases, you will get a capex cost reduction. So the bridge example was one where manpower costs were really high, and you strip those out, and you can afford to use stainless very easily. In other structures where you're not thinking modular, and I know this webinar was about modular particularly, you can use stainless in a selective way. You just have to understand where corrosion is going to occur. And that's something that World Stainless can help people with. We know where and how corrosion occurs. Some of the big construction companies understand that rather well too, and they design with partial use of stainless. So I'd prefer, from a stainless industry perspective, it's more use of stainless, but partial use is equally good. It's about understanding your operating environment. And if you understand that, you can make perfect material choices and still save a lot of money. But it does require a bit of careful thinking. That's all it requires. But it's different thinking. So I hope that answers the question.
Thank you, Tim. Can we do one more?
Of course we can, yes.
Then I'll ask Mr. Goyal to unmute so he can pop his question.
Sure.
Don't know if that worked. Oh,
Can the
I
gent...
think he... No, but it says, has anyone started this project in India? Do you know?
I don't believe so yet. But I wouldn't be surprised if that comes quite quickly. Because I think from an India perspective, and I had the pleasure of meeting the Deputy Minister for Steel earlier this year in India, there is no doubt that the benefits of stainless steel are becoming better understood in India, and the use of structural grades like duplex stainless steels are developing relatively quickly now. India has lagged in the use of duplex stainless steels for some time, not that they've not used it, but it is a little bit more difficult for the manufacturers of stainless steels to produce. So there's a learning curve, but I think India's on that track now. So I can see that those changes will come in India, and the Indian government definitely want to increase the usage of stainless per capita. So they have an ambition because they recognize the benefits of this incredible family of materials. So I think the answer is yes. They're on the board now, so to speak, and progress will be seen. And there's no doubt that infrastructure developments in India will benefit from the use of stainless, some in more traditional applications and some in modular ways. So I hope that answers the question.
First question here is, it says, in Europe, a key requirement is about insulation and inertia of the building. And how are such modules performing?
Well, that's a really good question because I think the hold-on system has been widely used. Well, it has been widely used in China, and obviously, insulation is built in already into the modular hold-on structure. So that's where the sort of glazing system and the use of insulation materials from the structural exterior to the interior walls is applied. Based on the information we've been given from the Broad Group, they've performed really well so far. It's a fairly new concept, so we've not got many years of experience, but there have been no negative pieces of feedback with regards to those two features. So it's something we need to keep an eye on, of course, to make sure nothing unusual pops up. But there's not been any sort of bad press, negative comments, or unsatisfied customers so far. Any other questions, Joe?
Yes, they are. The question, there's somebody who has two questions actually, and they're quite
Okay.
long. So it is about the standards. So for these, the production of these modules, are there any standards that are being developed that will clearly apply to them? Because in Eurocode 3 and everything applies to all structural steel structures. And this person is interested to know whether there is a standard that exclusively applies to these stainless structures in terms of the environment, health, safety. And then I first let you answer that question or continue with the second question?
Okay, that's a really pertinent question, and I know I can't answer that question at the minute, but what I can do, if the questioner is happy, I will take that and get a full response and email the gentle lady back.
That sounds like a good idea, Tim. And so the second question is, it says stainless steels are more difficult to weld and therefore the welding technology for them is more expensive. If the modules were made of that type of steel, so stainless, what standards would apply to them?
Well, the interesting things about these modules is that they're bolted together, they're not welded together, in essence. So any welding that is required, I should have said that's on site particularly. Any welding that is required in the whole-on building type concept occurs in the factory, where you've got people who are trained to weld stainless to the required standards. So when it comes to the installation, there's no welding required. So the whole process is simplified. And then things like the modular bridge, that's a very limited amount of welding that is required, but it does meet the required standards for that sort of application. So I think one of the whole benefits of the modular approach is that you are trying to eliminate welding as far as is practicable in this approach. So it becomes less of an issue. I hope that answers the question.
I guess it would, Tim. It does for as far as I'm concerned. Next question. It says, is it possible, and I think this applies for the modular housing, is it possible to consider the use of the lean and light duplex also?
Well, the grades used in the Holon system are lean duplex, so they're already considered. And that's because the lean grades, the environments these things have typically been installed in so far, do not require a higher level of corrosion resistance. You don't have to go to the higher duplex, super duplex grades. So the lean duplex is a good product of choice for these solutions. It's also been used for the modular bridge. It provides very high yield strength compared to other material choices and sufficient corrosion resistance for the operating environment. So I would say what's been chosen so far is the appropriate grades from the duplex family, and there isn't, unless you're going into sort of absolute marine environments, to choose a higher alloyed duplex grade. But understanding the environment is really important when you're sort of making these material selection decisions.
Okay, thank you. There don't seem to be any more questions at the moment. So
Okay.
I guess we can then conclude the webinar, can't we?
I guess we can. And just to say to people, thank you very much for your attendance. You can always send additional questions to info@worldstainless.org. If you think of anything after the event, we're still happy to answer questions. The webinar is the sort of window for going through these topics, but the ability to ask questions is always open. So, and I'll get back to the gent on the question that would have taken a very long sort of response, but also I'd like to check a few things as well to get a very clear answer to that question. So I guess, yes, thank you everybody, if there are no further questions. And we look forward to welcoming you to a webinar in 2024. For those people that are celebrating Christmas, I hope you all have an enjoyable festive season. For people that have celebrations coming a little later in time, I also hope you enjoy those celebrations too. Take care, stay safe, and think stainless, please.